This is ELC131, Circuit Analysis 1, and in this video we'll look at the analysis of another series parallel circuit. Now our series parallel circuit analysis always starts with recognizing the relationship of the components. Then we reduce the circuit by combining series components and or parallel components. Each time we combine these components, we result with an equivalent circuit. We continue to reduce the circuit combining series only or parallel only components until we have finally derived a circuit that is a series only combination or a parallel only combination. At that point, we can find the total resistance and the source current. If our reduced circuit is a series only circuit, we find the voltage drops in that circuit. If our reduced circuit is a parallel only circuit, then we find the branch currents. We transfer those voltages or currents back to the previous circuit reduction, working back to the original circuit, finding the voltages and currents. So referring to the circuit of figure 1, we see this is a series parallel circuit. And the first step is to recognize the relationship of these resistors. And hopefully we can see that resistor R2 is in series with R3. Whatever current flows through resistor R2 has to flow through resistor R3. And hopefully you can recognize that resistor R1 is in parallel with the series combination of resistors R2 and R3. So we can state that VR1 equals VR2 plus VR3. And also, I hope you can recognize the fact that resistor R1 is in parallel with the source voltage. So we can also state that VS equals VR1. Now, the first step in our circuit reduction is to take the series combination of resistors R2 and R3 and replace them with one equivalent resistance that we'll call REQ23. REQ23 has a value of 500 ohms. And referring to the circuit of figure 2, you see that we have now a simple parallel circuit. So we can find the total resistance using the product over sum of 120 ohms in parallel with 500 ohms and come up with a value or yield a value of 96.8 ohms. At this point, we can find the source current. V source divided by R total gives us 124 milliamps. Now, going back to the circuit of figure 2, our simple parallel circuit, we can find the current through each of these branches. IR1 is 12 volts divided by 120 ohms, 100 milliamps. And the current that flows through the equivalent resistance of resistors R2 and R3, 12 volts divided by 500 ohms is 24 milliamps. Now we'll take the 24 milliamps that we calculated for the current through IREQ2 and 3 and know that that 24 milliamps flows through the series combination of R2 and R3. So we can calculate the voltage drop across each of these resistors. VR2 equals 24 milliamps times 200 ohms, and VR3 equals 24 milliamps times 300 ohms. So the calculated values for the circuit of figure 1, I source is 100 milliamps, IR1 is 100 milliamps, IR2 equals IR3 equals 24 milliamps, VR1 is 12 volts, VR2 is 4.8 volts, and VR3 is 7.2 volts.